welcome to Class 3 in ME470. I decided to record a series of videos just for to help with the introduction to gears, nomenclature, and kinematics. I'll try to break this up into several videos. So here we go. Today we're going to talk about the nomenclature, dimension relationships, and gear pair kinematics. These are the things that are covered in chapter 13. Okay, so there's several classes to do this. We'll talk about gear trains. That includes planetary gear sets. We want to look about speed reductions or increases, and then the directions of shafts and the input versus the output. We'll also look at gear forces. So that's the topics that are covered in chapter 13, and we'll break them into about 3 classes. So we start out with the types of gears, and I'm going to switch to looking at my document camera and going through the prepared notes. So let's switch over, and I have a lot of demos to go through here. So right here. Okay. So if we're going to, it's good to have like little categories of things. So let's break things down into different types of categories here of gears, basic gears, right? These aren't necessarily gear trains, they're just 2 individual gears that are connecting to each other. So I have some pictures here. We have spur gears, and you can think of the spur gears like spurs on cowboy boots, right? They're just basic gear lobes that are connected to each other, just straight out. You could contrast that with helical gears, which have a slant to the gear, right? Possibly the best way to explain this is to take a look at 2 different examples, and you can compare and contrast where we might have, these are spur gears, right? They come straight out. And you can see their interaction between each other, right? And when you look down at them, right, they're going straight across. As opposed to helical gears, which, when we look right there, they have a slant to them, right? So they're not straight out. So when they meet right here, there's like this rolling action more on the face. There's more surface contact because it's a diagonal line right there. So that is your helical gear interface right there. And we'll see there's actually an interesting scenario where we can make them perpendicular to each other. It's kind of interesting. I need to get a demo unit that does that. I might try to do that like as soon as possible here. And then we also have bevel gears. A bevel gear, it looks, let's see, I have one right here, are these guys. If this thing will let me rotate the shafts right there, you can see how they are perpendicular to each other. So this for some operations, this is very useful right here. And then worm gears. A worm gear. So now we have a worm gear. Looks like this right here, and you've probably seen this before. Guitar tuners are like a worm gear. And what's interesting about these is you can't make this rotate by turning this, right? It doesn't make it. I mean, just innately you could tell that this is not reversible because you can't make this one will turn that one, but this one can't be used to turn that one. And I have another gear. I have another worm gear demo unit right here, so you can see. And you can see in this one in close up, you can start to see what's taking place. And my worm gear in my snowblower broke, so I need to find a replacement. They want $675 for the entire unit, but you could find gears that are similar to them, these little bronze gears, for like $10 on eBay, but I can't quite get the right one just yet, so I'm still shopping around. I have nice little pictures of these in my slideshow right here, where you see here's your spur gear, and there's a difference depicting there is your helical gear. Here's your bevel gear, and then there's your worm gear. I thought that one was an animation. So when dealing with gears, we need to establish some nomenclature, right? So I have there's a picture out of Shigley. Here's out of another book right here. So we want to try to make sure that we know these various parts of the gear, and this is the kind of stuff that's easy to ask in a multiple choice question or a match the thing question and that kind of thing. I don't usually ask it, but something you could be asked. So just to try to pay attention. We start out with I say to tell them this first. So let me see, which one am I supposed to tell you first? That something we call pitch. It's for U.S. gears. It's the main thing that we use to classify gears when we go to a catalog and we want to try to pick the gear out, and it's called pitch, but they actually mean diametral pitch. But pitch is sort of like a general word that we could use for lots of different mechanical things. Quite often it means like the distance something moves with one turn. That could be a definition of it. Also, a lot of times it's like threads per inch is the type of idea right here. So that's what this is right here. It's capital P, and it's the number of gear teeth divided by the diameter right here. Okay, so it's not exactly threads per inch, but it is called or teeth per inch, but it's teeth per inch because there's number of teeth divided by inch right here. But in terms of a physical thing that you might think of, it isn't exactly to have a physical, you couldn't count the teeth per number of inch, right? It is just the number of teeth divided by the nominal diameter, and this is called the pitch diameter, right? And so we need to define what that is, which we will on the next page. But recognize it's like the main thing, right? Diametral pitch, number of teeth divided by this nominal diameter that we're going to call the gear, which will make more sense when we see how it's laid out. And that's an important thing. All right, so we define the first item right here, this number 1, by this thing called the pitch circle, which you could see right there. There's the pitch circle here. I've also labeled it right here, so you can see the pitch circle, and that's the circle that is that pitch diameter, that main diameter right here. So we go, the pitch circle is an important one to have, right? And to find that, you get to find that pitch circle diameter, you take the number of teeth and divide it by the pitch, the diametral pitch, right? So you can just see that these are just interchangeable equations right here. But quite often you might look up in a book, it might be you want to pick out a certain gear, and you say, well, I need to have 20 teeth connected to 40 teeth. I'm not sure if that's the right number right here. I should probably count these. And then you pick out a catalog what pitch. That'll determine the diameter, right? You take the number of teeth, you pick in the catalog, say, I want this pitch. And different pitches have different traits. We'll see that there's some issues. Well, of course, with the diameter and the layout of the thing, but also in chapter 14, we'll see that stress also plays a role in why you would pick a different pitch. Now we start to go with another one here is the addendum circle. The addendum circle. And the addendum circle is number 2. You can see it's the outside diameter, right? And so you'll see here's the outside, the addendum circle right in there. We could even put a little 2 next to that. I guess we should have put a 1 next to the pitch circle. So the addendum circle right here. And the addendum, we could say, is this distance A, lowercase a. You can see it right there, or you can see it's right here, right? And so this right here, the addendum, that's the addendum. I'm not even writing distance, just dist right here. And that's going to be A. And for a typical gear set, all right, so there's various different kind of configurations, but for the most typical one in US gears, you can find the addendum distance by 1 divided by pitch. There's nothing that says it has to be that, but that when the layout of a gear, that's the typical distance. That addendum, it just happens to be 1 over pitch right here. Now, when it comes to SI gears, they use something called the module instead, and that turns out to be the distance of the addendum right there. So, they use module instead of pitch to classify and categorize. So if you were to go to a catalog, a gear catalog, it would be arranged by module. And you can only use gears that are of the same pitch together. You can only use gears that are of the same module together. Now, once again, this module is by definition lowercase m, which is a little troubling that they use lowercase m for a lot of things. And it will be 1 divided by pitch, but turned into millimeters, right? So remember, this is teeth per inch. So if you go the other way around, it's inches per teeth, right? So it's just inches is just the dimension of it. For SI, module is in millimeters, and it is the categorization, right? So we have the big ideas are pitch and module. US gears categorized by pitch, SI gears categorized by module, and it also happens to be often this distance. But you can make a gear and then put it on to a lathe and then make this shorter, and they do that. They're called stub teeth, right? And we'll see that's going to help with something called interference. It will reduce the chances of interference in some gears. So, but just this is like the big idea when trying to form out the size of gear. The next circle that we have right here is the I might skip this one. It's easier to understand. I'll go to 4. Somebody else labeled these right here. I'll go to 4 right there. 4 is the dedendum circle, right? So this is the addendum circle. This is the dedendum circle. And so B, lowercase b right here, that distance right there between the pitch circle and this root right here. So you could even, the dedendum circles also, it could be the root circle too. I think there you could actually, if you wanted to, you could make you could make them lower or higher. I think there's another category, so it's not listed on this particular nomenclature, that is the root circle here. So we can have the dedendum distance, and we have B is equal to, now this is just typical. There can be, we could look up in a table in a later part of the book where we'll see that there are other configurations besides this, but typically it's 1.25 divided by pitch. So it's 25% bigger. The dedendum is 25% bigger than the addendum, right? And I accidentally made that number 3, should have been number 4, right? So we're talking about that guy right there. And also, you can see that that's the dedendum circle is the bottom one right there. So I should have put that there, dedendum. Now, if you were going to take a look at 2 sets of gears to each other, right, they aren't going to be like crammed in. There's going to be a slight amount right here, right? So the top of this circle does not pass through and touch the root right here, or the dedendum, right? So the addendum circle of this gear does not touch the dedendum. So if you were to find that location right there, you would have the clearance circle, and which is number 3 right here. So that would be clearance circle. Clearance circle. And that would be C right here, right? But you got to see that you have to see the other tooth from the mating gear would be right here, and its addendum wouldn't pass lower than that. So that's like the clearance between the addendum circle of another gear and the dedendum circle of this gear. And the same thing would be true up here. There'd be the mating gear right here. It would have a clearance. Dedendum is like right up in here, and it would have the same clearance from the top of the tooth to the root of the tooth. That makes sense right here. So that was the clearance. Now we continue with some more nomenclature here. They will change this in some places just a little bit, but this lowercase p is now going to be the circular pitch, right? So this is circular pitch. They won't always put that lowercase c, but quite often they will. So they'll write that as PC or just lowercase p, and that equals pi divided by uppercase p, or diametral pitch. And this one, circular pitch, is a physical thing. That's the number of teeth per inch, and of course it's along the pitch circle, which is actually somewhere like right in there, right? But counting along the pitch circle, we're able to have the number of teeth per inch. And so the circular pitch is kind of closer to what we would refer to as pitch in other instances, right? Pitch in bolts is the number of teeth per of threads per inch, right? So but here this is circular pitch is going to be a measure, and this is actually inch right here. So this is these are measures. So this is really, and by the way, this is an arc length. You can also change this equation right here. You could take the pitch circle, divide it by the number of teeth, and multiply it by pi, right? So if you have the and you know that it's notice that's the circumference right there, right? D pi divided by the number of teeth, right? So you just take the distance right there and divided by the number right there. And this is an arc length too, right? Make sure you're going to be careful with that. So what you could do here is you could like start counting, right? A tooth right here, and this 1, 2, 3, right? And then you could have that measure right there, and you can find what the circular pitch is going to be. We also have tooth thickness. All right, so now often this one is a little misunderstood, right? So I've heard people misstate this tooth thickness right in here, which, let's see, oh, by the way, I needed to point out on the figure where the circular pitch is located. You'll see right there is circular pitch. They have, it's this distance from here to right here. So at the start of one tooth to the start of another tooth is an arc length along the pitch circle. And you can also see it right there, right? Okay, so they have, this is actually the stop to the stop, if depending on which direction you're going, I guess. But that is circular pitch. And then we get the tooth thickness. The tooth thickness is right here, right? So right along, we're measuring it along the pitch circle. And so here you go right there. There's also the tooth thickness right in there. So now the most it can be for a tooth thickness is 1/2 of the circular pitch, right? But this is an approximation. If it actually was exactly perfectly there, we wouldn't be able to have, there is some amount of flexibility of the center of the shafts, how far they get away from each other, right? And we'll actually have a little discussion of that. But if they were too close to each other, they would be, you know, if there was exactly the tooth thickness, you wouldn't have anything. There's something called backlash, which when the gears are put into their centers, you can, if you hold one steady and you rotate the other, you will have this thing called backlash, and it's a good thing to have so you don't have too much. They could get stuck together, right? If you really cram the two things together, there's no backlash to it. They could kind of bind. But also, some gears need to be able to reverse, and when they reverse and there's backlash, there's going to be a slapping of the gear teeth together. So there's lots of these little subtle things. I don't want to have to teach you I don't want to have to throw all of that in the kitchen sink. There's something called an undercut distance, and that's not shown on here, but it is right here. What happened? I don't know. My computer just decided to blink. That was scary. All right. And an undercut, we can show it a little bit later, is part of the machining process, but also can help with something called, with that interference that we will discuss. But you could see kind of right from this right here where that undercut is. So like, do they show? Yeah, there it is right there. There's the U that they're showing. So this is the undercut. And that helps with interference, but also makes this the root of the tooth, or I'm going to be careful with the root. There's another name for the root. But the strength of the tooth is reduced because of undercut. Because you can think of these as cantilever beams. So we've made them smaller down here where the stress is the highest. So we have an issue there. Other things. Let's see. We covered number 5. This is the bottom land. So you can see right here, bottom land. You got 6 is the top land. That is right here. You can see right there. There's number 6. And number 7 is the flank. Oh, I wrote plank instead of flank. And the flank is like this lower part right here below the pitch line. And then lastly, we have the face, which is this top place right here, right there. So there you go. There's number 8 right here, and there's flank right here. So here's the gear nomenclature. It's a good place to break off, and we'll go to the next video here. Hopefully they give you like this big introduction, give an idea of the various things that we care about in naming gears, naming the parts of gears. So that's how long of a video is that? 22 minutes. That's too long. Gotta be more efficient.